In this video, we're just going to take a quick look at solving some equations that involve exponents like we've been working with in the last few classes where we've talked about growth and decay of functions and some attributes of what those graphs might look like. The equations that we solve, fairly simple to work with as long as we know a procedure. And part of that procedure is being able to evaluate exponents. So we're just going to take a quick practice there before we solve some equations, going back to some basic ideas of what exponents mean. For example, in case number one here, we have we want to evaluate each expression, and the first one says 9 to the power of 3. And we could remember what that means. That would be a 9 times 9 times another 9. So taking a 9 times itself. So there are three of them. And that number gets pretty big quickly. You might know that 9 times 9 is 81, but then 81 times 9, not as quick as we have. So what we have available to you on the back of your notes page here is a base chart that walks you through all some of these common expressions. It goes all the way up to an exponent of 4, for example. So if you wanted to know what 9 to the third is, what you can do is you can go to this central column that says b to the first, go find the number 9. And if you go from 9 all the way over, this is 9 to the first, one spot over would be 9 to the second, there's 81. One more spot would be 9 to the third, which says 729. So we're in the row of 9. When I go over to 729, if I stay in this column and go all the way to the top, I'm lining up with an exponent of 3. So that is how I can evaluate 9 to the third with our base chart here a little bit faster and trying to do this calculation in our head, maybe even then grabbing a calculator. So for this very first case, we have 729. It'd be the same idea for 5 to the fourth. That just means 5 times 5 times 5 times 5. And you could multiply those yourself, but again, practicing this base chart here, if we go to 5 right here, and this is 5 to the first, move over to 5 to the second, 5 to the third, last column is 5 to the fourth, and that tells us that this is a value of 625. So we're lining up with that exponent of 4. And this base chart's going to help us out because we're going to be solving equations that involve these exponents, and being able to see all of the possible values within a row helps us do a little problem solving a little bit faster. It might also help us out with this next part where we throw a negative exponent in. We know that 7 to the second means 7 times 7. But 7 to the negative second, it is still 7 times 7. However, when you take that 7 times 7, a negative exponent means reciprocal, so it's going to put that multiplication underneath a fraction for you. So if you know that 7 times 7 is 49, we can see that this is going to end up being 1 over 49. However, using our base chart here, you could also go find 7 to the negative second, so going down to 7. Okay, so this row here, and then this is 7 to the first. When you move over one spot, that's 7 to the negative first. They both use the same value. That's 7. Go over one more spot, that's 7 to the negative second. So if I go to this 1 over 49, I'm in the row for 7, but if I scroll all the way up, I see that I'm lining up with an exponent of negative 2, which tells me that 7 to the negative 2 is 1 over 49. We could do the same thing with 4 to the negative third. Let's go to the row of 4, go over to a power of negative 3. So here's 4. 4 to the first, move over to the left. 4 to the negative 1, 4 to the negative 2, 4 to the negative 3 is 1 over 64. And again, you can see that at the top, we're lining up with an exponent of negative 3, and we're in the row of 4. So 4 to the negative third is 1 over 64. Okay, so getting used to exponents, wanting to know that positive exponents give us a whole number, while negative exponents, they don't give us negative answers, they give us fraction answers, okay? Negative exponents represent that fraction format. So when I'm looking down here, kind of reversing it, I'm giving you the answer. Can you now tell me what exponent would go with it? And when I see a fraction like this one, I'm already thinking, I need a negative exponent for this to work. So what I'm going to do is go to the row that has 6, find the exponent that makes this true, okay? So I'm going to go look for 1 over 216 in the row that says 6. So here's 6. I'm scanning. We got whole numbers to the right. Don't want that. We're going to the left. And if we look here, here's 1 over 216. Go all the way up, and that says 6 to the negative third. We're in the column for negative 3. So we're in the row for 6, and we're lining up with an exponent of negative 3. So this is going to be 6 to the negative third. And we're going to do that with the next three cases too. 1331, 1,331 is equal to 11 to the something. Not something that we have memorized most likely here. So if we, again, scroll down, go find 11 in your row, go all the way over. There's that 1,331, and that is, we're at 11 to the first, 11 to the second. This would be 11 to the third. You can verify that at the top. We're lining up with exponent 3. Okay, the next one you might have memorized, it is 144. Suggestion is, let's go look in the row for 12. So again, go down to the row of 12. Here's 12 to the first. One spot over is 144. That would put us at 12 to the second. And the last one is 1 over 64. Now, we saw that just above here, right? You see how there's a 1 over 64 in both of these places? Up top, when we said 1 over 64 was 4 to the negative third. But down here, I'm suggesting that it could also be a base of 8. So if we go to our row that says 8, we're going to find the exponent that would also make this true. So sometimes these numbers show up in multiple places in this chart. We have to pay attention to what row we're in. So if we stay in the row for 8, we're not going over 3 spots. We're just going over 2 spots. So we see 1 over 64 is in the column for negative 2. So again, we want to pay attention to what base we want because this fraction showed up in 2 different places. It showed up in the row for 4, also in the row for 8. Okay, so you're not going to have to do too much with thinking this way today, but as we solve more complex equations, this kind of thinking is going to help, knowing what kind of exponents are going to give us certain expressions. Okay, so you have that base chart, hold on to it because it'll help you out. Now, as we go down, our real goal today is just to solve equations that have exponents, and you're going to see variables in those places, okay? So what we're going to do is just look at 2 examples here, and we want to, in step 1, write each side of the equation with the same base. That's not going to have to be something that we worry about today. This will already be taken care of today, so we're not going to have to worry about changing anything around today. So we're going to get used to equations, but the next time we solve equations, this is a step we're going to want to draw attention to. But we're going to see that they have the same base already. That means the value underneath the exponent, the big number written at the bottom. So what we're going to do here is look at example 1. When you look at number 1, when we say write your equations to have the same base, what we're saying is this. You have your equal sign here in the middle, and on each side of the equal sign, you see the number 3. And 3 is called the base of this expression, the part underneath the exponent. And what we see is the left side has a base of 3 and the right side has a base of 3. They both have the same base. When that happens, here's all you do. We say if the bases are equal, this is now step 2. If the bases are equal, then we can drop the bases and set the exponents equal, okay? So what we're going to do now is we recognize that each side of this equation has a base of 3. So if we're going to solve this, all we need to do is take exponent 1, so it's 2y minus 1, set it equal to exponent 2, which is 5. That's it, okay? So we recognize they have the same base. We drop those bases, and we just write an equation using the exponents now. And all we have to do now is solve that equation. So solving equation, going back through steps that we've seen many times in our past, if we have 2y minus 1 equals 5, we see this 5 does not have a y, so we're going to bring the other number that does not have y over to it. So we're bringing over this 1. So we're going to cancel the minus 1 by adding. Those are gone. That gives us a 2y over here equals 5 plus 1 is 6. And then dividing here, whenever you have a coefficient before the variable, divide to cancel. So we're going to divide by 2 each side of this equation and get a final answer of y equals 3. So that is the step we're practicing today. The work today is very familiar, but the step we're practicing is recognizing that the base is the same on each side of this equal sign. Same thing on number 2. It doesn't always have to be a base of 3. It could be any number underneath those exponents. So when you look at number 2, you will recognize that the left side has a base of 7 and the right side also has a base of 7. So I'm circling those to draw my attention to that. Both sides of this equation have the same number at the bottom, okay? The same base. And as soon as you see that, what you're allowed to do to solve this equation, what you need to do is set these exponents equal to each other. So the exponent here says 6x, the exponent here says 2x minus 20. Okay, so we're going to solve for x. What we need to do then is look at what we have. We have x in two places, okay? So we need to get them together. So we have 6 has an x on the left. So what we're going to do is bring the other number that has x over to it. So on the right side over here, we have this positive 2x. We're going to cancel that by subtracting. So minus 2x each side of this equation. And that's going to give us a 4x over here equals, the 2x's cancel, so we have a negative 20. And just like before, you have a coefficient with x. So we're going to divide by 4, okay? If you're wondering where the negative 20 came from, remember we have to keep this minus sign there. But we're going to divide by 4 to cancel that coefficient that we have, and that's going to give us x equals negative 20 divided by 4 is negative 5. So in your practice today, you're going to see equations that have the same base. You're going to write new equations that just use the exponents and practice skills, okay, that you've seen before. They might look very similar to one of these. That might be slightly different, but similar to things that you've practiced in your past.